All right, welcome everybody. My name is Peter Sigurdsson. I will be your instructor here in virtual system administration. So some of us, half the room are in here in class in the room, and half of you are over there. So anyway, we'll be getting started in a couple of minutes. I'll kick out the recording as well. So if you want to review any portions of the class, the recording will be up there. Welcome everybody. Hello. We'll be getting started in a couple of minutes. Welcome. We're getting started. I'm going to give it an extra couple of minutes today, maybe 2:15 to because the room number changed and all that. If you guys want to get it, you probably know the area right from the gas station across the street, which have workers. So they have the Burger King across the street. They have better coffee for Burger King. Anyway, I'll start at 2:15. If anybody needs to take some refreshment, you have a couple minutes to go get that. Audio test. All right, we've got a working projector, great. All right, folks, I'll be getting started at 3:15 today. Just normally we'll start like 3:05 or something, but give it an extra couple of minutes a day for everybody to get organized. Like 3:05 or something, all that stuff. Just gonna leave off the lights when I'm projecting to make it easier to see the projector. All right, folks out there in virtual meeting land on my online meeting. Hopefully you can hear me okay. If you can hear me, just type yes in the chat box. And sometimes I'll be drawing on the whiteboard or something, so I'll be projecting a camera. But for right now, just as long as the audio is, you can hear me. Very good. Thank you so much. Randeep, we're getting started in about 10 minutes now. Okay, we'll be getting started in 5 minutes. All right, it's 3:12. We'll get started in a couple of minutes.
Starting in person next week, so not. All right, welcome everybody. My name is Mr. Sagerson. I'm going to be your instructor here in Systems Administration. And of course, I'm going to be starting in person next week, so we're on. So we have made some updates to our page, all the page. Still not get access to it. But I'd like to just take a couple minutes before we break that. Get your brain to know some kinds of topics, concepts. And you take a look at the PowerPoint. But again, you're probably not going to understand much about it. So the basic kind of model of this course is that computers at a very large scale. Computers require a sort of complex set of processes. We call it administration. And these days, in fact, for about the last 50 years, computer trend has been centralized computer servers or data centers in certain locations around the world.
All right, guys, I suppose we're supposed to get started now, so let's do that. First of all, let me close all of this stuff. And we're going to start with a little quiz. This quiz does not count for marks. However, it is an attendance quiz as well. These are some of the real questions you're actually going to see come final exam time, right? So it'll start familiarizing your brain with the concepts. I don't know, it should take about 10 minutes or so to go through that. So I'm going to kick that link out to your classroom. You can go over there and click on it and get started on that. So my online people, here is your quiz link. And my in-class people, you can get it from over here, which is the page, right? So day one attendance quiz. Plus showing you the final exam questions for all purposes. All right, guys, so go there now and do that. And a lot of these questions, in fact, I can say probably all of the questions will talk about things you've never seen before. That's okay, just do your best to come up with some kind of an answer, and then we will discuss it. We will then look at the course outline. Audio level test, online people. If you can hear me, type yes, just to give me a feedback. Yeah, so, and then we'll go over learning plan, and then we will start on our first topic today, which is what is server virtualization. Great, thank you so much, Robin Deep. Thank you for the feedback. All right, let's see how you guys are and ladies are making out. Nobody is writing my quiz. Click on the link and write it. The title of the test is wrong. That's from a previous term, but that won't hurt anything. Welcome, come in. Hello, who's there? I just see a hand. Come on in. Yes, this is virtual server administration. Thank you so much. All right, ladies, we're writing a little quiz. Just go to your, I thought let's get the final exam over now so we don't have to stress about it. The link is in your class marker. I just have to fix up my screen, then I'll blast it out and show it to you. All right, so ladies who just joined us, you can head over here to classroom. See, it says day 1 attendance quiz. So just click on the link and go and start doing that. All right, great. I have 28 people writing my quiz. Good. So we'll wait till you guys and ladies finish up, and then we will go over it. We'll discuss it briefly, and then we'll review the course outline. Then we'll actually start working on learning the material of the course. Come on in. We're just writing a little quiz here, so we're just getting the midterm exam out of the way because I don't like waiting to the last second for everything. So just jump in there and start writing it. It is up there in your classroom page, day 1 quiz, right? So just go and click on that link and get to work on that. They finally cleaned it off. The first term Pierce College was in this building, which was May 2018. They didn't have whiteboards and I was in this room. So I used to write on the class with my markers to write when I'm talking. And for a couple of years, the marks were still there. I see they finally cleaned them off. Anyway, that's enough about me. Let's talk about you for a while. So jump in there and work on that, and then we'll go through the answers together. Now, some of the concepts I'm sure you've never heard about before, so don't stress it, just do your best, and you don't know the answer to something. Yeah, some computers are not. Well, what about these? Do you think maybe these are working? Give this one a try. Oh, here, I think maybe that one's doing something. No, it's a collect button. Yeah, actually, it's preferred if you use your laptop because you're the administrator of your laptop, and a bunch of the exercise we're going to be doing will be kind of kludgy on the desktop. If you can bring your own device, that is far and away. That's the way to be much better to do it. Yeah, bring your own device if you can all manage to do that. Now, this tool, which is class marker, this will be the actual test tool we will be using when we get to the real tests and stuff. So you're getting familiar with the test tool, the types of test questions, and some of these will actually be the same questions on your real test, right? So pay attention, do your best. All right, online people, how are you guys making out? All right, about half the class is finished and a number of people are still writing. So I'll give another few minutes for everybody to catch up. Now, these numbers don't really mean anything, the percentage, because most of these need to be manually marked. So I don't know, pay attention to that. All right, I think virtually everybody is finished. A couple of people are still writing. So you guys who are still writing, keep going. Meanwhile, we're going to just grab somebody's work here at random and take a look. Now, bear in mind as we go through this, I don't expect you to know this stuff, so don't sort of get upset and think, I'm going to fail this course because I don't know any of this stuff. No, this is the stuff you're going to learn here. So I actually am surprised if you do know any of this stuff. Maybe you took some other training, or maybe you worked in some job in a DevOps role or something. This is just to expose you to the kinds of concepts we will be talking about here. All right, let's look at somebody's work. What is an operating system patch and why are they important? Yeah, so they're fixes, exactly. So this student got it, and most of us are on Windows, so we know that Windows isn't as bad as it used to be. It used to be if 2 days went by and you didn't have to update your Windows, you wondered what was going on. Macintosh, they're more disciplined, right? They have patches maybe every 3 months or something. Same with Linux. Linux, you don't actually ever have to update. You can update whenever you want to update the latest service. But we are going to be dealing with operating systems. They will be one of our concepts here in virtual system administration. In fact, this course is kind of, I don't want to say confusing because that's a negative word, but unlike a lot of courses which you might be used to taking, where there's sort of one concept like Java programming, for example, well, Java programming is one thing, but this course involves probably about 6 or 7 different concepts, and you have to organize them together in your brain. And one way that I can help you to do that, which is how I help myself to learn things, which is to draw pictures and diagrams. So we're going to use Visio, and we're going to capture our concepts here in this Visio diagram, and I'll kick it out to you as a JPEG image, and hopefully that might help you a little bit when it's time to study for the tests. So let's go and capture some of our concepts here. Right, so the title of our course is Virtual System Administration.
सर बोल पे
which right away may trigger you to make the inquiry. Is there some kind of system administration which is not virtual? And yes, so anytime you deal with any computer, you're administering the computer, you're taking care of it. Even if it's your personal laptop, well, you're having an antivirus there, hopefully. You're applying updates to the antivirus. You're applying Windows patches. Maybe you're installing new software like Word or something. So to administer just means to do some caretaking activities. So the product, right, the hardware can keep serving you the way you need to do the job. Now we can imagine that if we were working with Google, for example, we'd have to be in charge of thousands of computers in server farms all over the world. So maybe some of them are in Chile. I know one of their big server farms is in the Chilean desert because they researched, they found out it's on a big sheet of rock. So if there's an earthquake, it probably won't get damaged. And Chile is a nice place, but the Chile desert, probably not so much. So you probably would not want to have to fly there and sit in front of the computer to administer it. So virtual server administration means you can access a computer somewhere else through some sort of a remote access terminal, right? Maybe some of you have worked with Telnet or something like that. So anyway, the title of the course may sound intimidating, but when you break it apart, it's just a series of activities which you've already been doing sort of on a small scale for yourself. Now, some of the stuff involved here are operating systems, because if we're administering computers, ultimately we must be doing something to take care of the operating systems. And that's one of the concepts here, which is reflected in this question. So again, the purpose of this diagram, I'll share it out to you every week after class when we're finished, but it is to grab the concepts visually and let us make a connection between them. All right, so let's go and see what else is in that question. I guess I better save this in case my computer locks up so I don't lose the work. All right, next question. Discuss the operation and use of virtual machines. What are they? How do they work? Why are they useful? How do they help us as DevOps? That's the new name for system administrators. In this course, we're going to learn to be development operations specialists, which just means network administrators. Well, I'll show you an example of a virtual machine. See, VMware is one that we're actually going to be doing some activities with. Whoops. Oh, I see. Yeah, because I was running out of space. I installed this on my portable hard drive, so I don't have it with me right now. But essentially, a virtual machine is like a little operating system that lives inside a bigger operating system. So now we've already said that an operating system is the software, right? It's the software. It's not like an application software like Word, but it is a program written in C programming language. And the operating system runs the computer, and we can have little operating systems inside the big operating system, which is called a virtual machine. Not going to go too much into it now since we have a couple of entire lessons and one of our assignments is about it. But anyway, that's that concept. So let's add that to our roadmap here. And a virtual machine actually is an operating system. I'm going to put it under operating systems on purpose. So you could, in fact, call it like a virtual operating system. Ladies in the room, girls, maybe when you were like a small child, you played with a dollhouse. So a dollhouse is like this sort of little small scale model of a house. So you were sitting inside your own house and you were playing with the dollhouse. And the dollhouse was like a kind of a virtual house in a sense.
It was like a little small scale model of the real house. So a virtual machine is like a little operating system that lives as an application program inside the big operator, the parent. Now, why do we want to do that? A couple of reasons, but we'll put off discussing that till we get to that lesson. Yeah, exactly. The student gave a perfect answer on this. I give pretty much perfect marks on this for the test. Virtual machine is an emulation. It's a model. It's a software rendition of an operating system, and it lives inside a bigger operating system. Great. With regards to the Windows operating system, I got to plug my computer in or the power will go out here. Hang on. So one of the concepts we're going to have to work with, in fact, we will need to work with several aspects of computer hardware. One of it is hard drive. Hard drive maintains file system, and NTFS is a kind of a file system. Again, I'm not going to spend a lot of time on that right now because we have an entire lesson on that, but it is a way of storing data, right? So let's add an element here in our roadmap for file systems. Of which NTFS is one, there's others, NT file system. And what is a file system? It is a format for encoding data for storing it on a storage device, such as a hard drive. And storage devices are something that as system administrators, we have to be in charge of administering. So the exact question here now was with regards to the Windows operating system, the NTFS file system. Yeah, it has certain characteristics we're going to get to. It relates to how data is stored and encoded. And your operating system, like every other software on your computer, is stored on the hard drive. So some of you may at some point in your life have wondered. I remember when I got my first computer, this is something I started wondering about. When the computer is turned off, there's no power, so it doesn't know anything. But at some point you turn it on and it loads its operating system, Windows, Mac, or Linux. How does it know that it's supposed to load its operating system when you turn it on? Anybody studied or looked into that? Any guesses on that issue? How does the computer know that it's supposed to load an operating system when it's turned off and it actually doesn't know anything? Yeah.
It's stored in the BIOS.
Very good, 100% perfect answer. So basic input output service chip is a little microchip on the motherboard. And then when it gets power, what does it do? Maybe you studied A+ certification or something. What does the BIOS do to get the OS there?
The BIOS is basically all the information about the computer, the bootable hard drives, and the.
Exactly. So it goes to sector 0 of the hard drive, which is the partition table. And you could have several operating systems on one computer. You could have Linux and maybe a few different versions of Windows. Exactly. So that's a great answer. So yeah, that's the kinds of things we think about here. Why? Well, a couple of reasons. Number one, if it breaks and doesn't work, we have to know that to fix it. Number two, if we're administering some computers, we may want the computer to boot up with a certain operating system. Well, how do you do that? A common way, not the only way, but a common way is to configure the partition table on sector 0 of the hard drive. What the freak is a hard drive? What's sector 0 on the hard drive? Next week, I have an old bag because I used to fix computers. don't anymore because computer hardware is cheaper than water now. It's cheaper to just throw the damn thing out and buy a new one. But a long time ago, before you were born, we actually used to fix computers. And I did that for a while and I kept some of the old parts. So I'll bring in like an old hard drive and an old motherboard and some stuff to just sort of show it to you. But a hard drive ultimately is a stack of metal plates called platters, and they have magnetism. And later I'll put the board up and I'll draw some stuff on the whiteboard. But essentially you have circles like donuts, do concentric series of circles on this magnetic platter. And the innermost one is called sector 0. And that's doesn't contain much information. It is just an instruction to the operating system to go to another sector to get the real operating system that should be used to move it up. Anyway, we're going to be installing multiple operating systems here in this course. And then we're going to see that. And if you're wondering how it's possible, we're going to install multiple operating systems. Well, we're going to be using VMware. Now, it will be much more satisfying if you can bring in your own laptop, because the classroom computers, we can't really do too much if you don't have the admin password and so on. And if you bring your own computer, don't worry, it's going to get damaged. It won't, because you can get the free 30-day trial of VMware Pro, which lets you make ISO files, which are kind of VM virtual installables of certain configurations of operating systems. And I can also make, as I do of the Pro version, I can make ISO images with different flavors of operating systems, like Windows Server 2012 and so on. If what I'm saying sounds very confusing to you, take a deep breath, it will all make sense within a week or so. But right now, I just want to give you some introduction to the kinds of things we're going to do here. So anyway, that's some stuff about file systems and storage devices. What are the functions and operations of an operating system? We're going to talk about that in a little while. There is good information on the PowerPoint. It's a very good PowerPoint. It was written by a very smart person. Okay, I'll admit it was me. But anyway, over many years of teaching this, guys, learn to take a joke. I'm not really crazy. People just think I am. This is material I developed during lecture while teaching things. So you could go and buy textbooks and read the same stuff. My discomfort with a bunch of the textbooks out there is they're written using words and terms and concepts, which the professors and the academics who wrote the book were quite familiar with, but students, maybe just not really having that background. So my material, I hope, is more accessible. It's written sort of assuming no prior knowledge. So anyway, we'll talk about the operating system, basically, and the kinds of ways I'm going to be teaching you to think about this is the way I think about things myself. So if you consider a computer, yeah, so we consider the hardware of the computer. It's the motherboard, right? Ultimately, it's maybe you've seen a motherboard. I'll bring in some old motherboards to show them to you, but it's basically this big circuit board, and it has these microchips on it. Right, it looks like this. So the motherboard contains pretty much all the hardware we can possibly have. Now, some things like the monitor, the hard drive, the keyboard are not on that motherboard directly, but we have things called interface mechanisms. In the old days, it was IDE, Interface Device Extension, I think it stood for. and ISA, industry standard architecture. And then for a while, we had EDIA, which I can't even remember what it stands for, and now it's mostly a USB. So if I have an external hard drive, I'll plug it into a USB port on my computer, but ultimately everything is hardware in the motherboard. So the operating system is in charge of managing all the hardware, right? So we have the hardware, which is the motherboard plus peripherals, like storage devices, peripherals. And then the other thing that we can have with a computer is users, right? So we have the people who are using it. And those are the two things which operating system is in charge of managing. If you think about it, what else could there possibly be? There actually is nothing else in a computer system. There's either the hardware or there's the human beings. So what does human being need? Well, user ID and password, for example. So then we have user accounts, and where the user accounts managed, that sort of evolved over time. Now we have a concept called the Active Directory, which is one of our topics we'll be doing some labs on. So we're going to fire up VMware on these computers, and I'm going to make an ISO image of Windows Server 2012, and then you're going to create some users and give them passwords, various levels of permissions to access or to deny being accessed, storage volumes, the interface, internet, the NIA network interface adapter, and so on. So yeah, either we have users or we have hardware. And similarly, just like with users, the hardware can have different profiles. So we could have the CPU, for example, and programs that application programs could be allowed, or they could be denied access to the CPU or to memory or to different storage devices. Users could be allowed or denied access to different application programs. So everything we have on the computer, if you just program this into your brain, it's either hardware or it's a human being. And we have accounts for both of those things. We manage the accounts in Active Directory, and then everything else builds on top of that. So it's a pretty simple model, and we're going to do some worksheets, and we're going to lock those concepts in. Let me go back, just going to go back, loop back to my virtual meeting and make sure we're all still here in virtual land. 30, what is it? 27 participants, good. So you guys online, are you all good? You can still see and hear? You hear my mic okay? You can see the screen. Any problems, let me know. I'll check the chat box.
Yes, sir. All good.
Well, nobody's complaining, so I guess they're all okay. All right, let's go to our next question. Yeah, functions of an operating system. So what does it do? It enables the use of hardware. I mean, you could say a bunch of things to that, but ultimately it controls or it denies access. It enables or denies access to hardware. It enables or denies users from doing stuff. Come on in. Yeah, thank you. Very good. You missed our attendance quiz. I'll get you going on it during the break or something. We'll give it to you later on to do. So just sit down and get a computer and we'll catch you up. You didn't miss too much. We just did our midterm exam. It was only worth 25% of your mark. You can still catch up with marks later. So anyway, that's that. A web server, right? So like Facebook or something or Amazon.com. So web server does which of the following activities? And we're going to also introduce now, the purpose of this question is we're going to introduce some networking stuff, because any server, basically since 1990, when the internet became a thing, had to deal with the concept of a networking stack. And sorry, I'm just going to wait for that siren thing to go away. It's a little bit distracting. So another concept we're going to have to work on here is TCP/IP networking, which is the basis of the internet, right? The internet works on a networking protocol called TCP/IP, Transmission Control Protocol, Internet Protocol, and we're going to have an entire lesson, week 7 or something, and we're going to have some labs and stuff based around that. Question? Oh, come on in, welcome. All right, so I have a couple of students joining late. Oh, you guys, maybe during the, I don't want you to miss your break. We had a quiz which you missed. It was actually the midterm exam, but it's okay. I'll give you the link. You can, why are you looking at me like that? We had to write the midterm sometime. Okay, it was just a little attendance quiz. It didn't count for marks, but she's scaring me. She's looking at me funny. Yeah, I'll give you guys the link. Maybe you can do it later tonight or something. Because the questions are going to be questions such as you will really see on your real live test. So I don't want you to miss out on that. So anyway, we'll talk about servers and web servers, mail servers, FTP, DNS, port forwarding. We have at least 2 or 3 classes on networking because that is a very critical part of server administration. All right, so class members who joined us late, the link for this quiz is here in Classroom, Google Classroom. So not now, because I don't want you to distract your attention away from our lesson, but maybe in the next day or two, whenever you have like 10 minutes or something. Yeah, so you guys, I think about 4 of you who joined us late, just give me your attention for a second. So here is your link. And the reason why you want to do that is to get familiar with Class Marker, which is the test tool, which will be for our real tests, as well as I'm going to give you these attendance quizzes every week, partly as a way of taking attendance and also to give you a sense of what kind of questions you're going to get when we really get to the real final and all that. So not now, but tonight or tomorrow morning or something, please go and do that. All right, so we've done our attendance quiz. Now we're going to review the course outline of the week learning plan, and then we're going to start talking about what's the purpose of this course, which is virtualization. However, it's about 4 o'clock, it's 3:55. Let's give it a break till 4:15. When we come back, we will go and review our course outline. We'll see what the schedule is for tests and assignments, and we'll preview the weekly learning plan. So we're now on break until 4:15. You guys probably know the campus, I think so, but there is a gas station across the street which has a Tim Hortons. There's a Burger King on the other corner, which if you want coffee, actually, in my opinion, the Burger King coffee is better coffee. So go and take some refreshment wherever you like. We'll start up at 4:15. I will practice my German speaking.
Excuse me, sir. Sir, studied this subject in the previous semester, and the instructor like installed us a virtual box inside. So we should install the virtual box, or should we do it in VMware?
Well, there's two. We're gonna be doing both Oracle Virtual Box and VMware. We'll be doing both. Yeah.
So like when we install the VMware, then we will have to like set up all the different things. We don't know about that.
Well, we'll go through that. It'll be some of our lab activities. We'll get to it. That's like week 3 or something to start working on that. We'll get to it.
Okay.
Yeah.
Thank you.
Yes.
All right, guys, let's carry on now. Audio level test. Audio testing. Yeah, seems like my meeting is still going pretty okay. All right. So. All right, Abhishek. Very good. AJ. Akashdeep Singh.
Yes, sir.
Where are you? Sorry, hand up. I just want to see. I want to start to learn your names. It'll probably take a couple of weeks, but I'll do my best. Amanat Kaur. Nope. Amaninder Singh.
Yes, sir.
Which one? Okay, very good. Hello. Aniket Singh.
Yes, sir.
Very good. Anil Kumar. Anush.
Yes, sir.
Arshpreet Kaur.
Yes.
Arshveer Kaur. Ashmeet. No. Bhupinder Bir Singh. Bikramjeet. Sharanjit.
Yes.
Dixit. Ekjot.
Yes, sir.
Ekta? Where? Sorry, I just want to learn your names eventually. It'll take a few weeks, bear with me. Elwin? Gagandeep Kaur? Kevanpreet Singh, very good. Gurjeet? Gurkirat? No. Gurswalk? Gursharanjit Singh? Gurshminder Singh?
Yes, sir.
Where? Which one are you? Sorry. Hello? Harjot?
Yes, sir.
Harakirat?
Yes, sir.
And Harakirat, student number ending 66.
Yes, sir.
Very good. And my online people, I have a way of taking care of them through the Zoom meeting. I'll manage them later. So that's pretty good. We're pretty much all here. So we're going to go through the course outline now. Oh, I think that's an Amber Alert or something, yeah. Okay, well, I hope whoever this is involved in is safe and God takes care of them, but it's not our thing, right? Sometimes there might be a fire alarm, but that has nothing to do with this building, so we can carry on. All right, so let's go over now to classroom and see the course outline, which will be sort of our roadmap, right? It'll be our control document as we go through this course. So the course PowerPoint is there. We'll introduce that in a few minutes. For right now, if you haven't watched the video yet, watch it. It's a pretty good video. Oh yeah, here's our course outline. Let's go through this. So this course is going to teach you about virtualization, which we can start by understanding virtualization has two concepts. Number one, it means we can have remote control over another computer. So from this computer, I could log into a computer in Australia and manage it, right? I could install, I don't know, antivirus updates or something. So remote control of the computer is one sense of virtualized control. The other sense is I can use virtual machines. And we're going to see later, there's a couple of reasons for running VMs. Number one is these days, like this computer in front of me and the computer in front of you, you're probably only using a couple of % of its capabilities. So at work, they might have a couple of big servers and they want to put 12 virtual machines on each one. So different developers can log into it and test their code and their database and so on. So virtual machines enables us to get more full utilization out of powerful modern computers. It lets us quickly create different configurations, and a very likely job that many of you will get, because I study, right? I pay attention to what kinds of jobs students in this program get when they graduate. And quite a few students go into something called junior or assistant DevOps specialist, right? So A development operations specialist is somebody who manages and takes care of the operation of the computers. Obviously, as a new graduate, you're not going to be in charge by yourself. You'll be an assistant to the big boss. But in that role, you might be configuring machines for developers, software developers to use to test various different configurations. So anyway, and also something which is quite a big deal these days. And I'm sure many of you have been looking at job ads and you've seen job ads asking for things like cloud services certification, Amazon Web Services, or Google Web Services certification. So this will also, I mean, it's not going to get you ready for either one of those certification exams, but it will start the process, right? It'll start to introduce some core concepts so you could go and study that. And cloud services is a very big deal to get into right now. So just like when I started at IBM in the 1990s, the new technology that was hot and everybody wanted to hire it was HTML developer. Now, in today's sort of job marketplace, the hot thing, which will get you fast-tracked into the good job, if you can start, and you don't even have to completely get it, right? To get Amazon Web Services developer is 5 exams. If you just write one, like even write the first one, which is introductory concepts of cloud architecture, and then you can tell that to the interviewer to express some interest at least, because if they need you in a cloud services role, they might pay for your training. But that's something I strongly encourage students in this kind of a program to be looking at. So anyway, that's what this course is about at the high level. We're going to be working on activities and projects that allows you to apply the concepts learned to real world scenarios. This course will provide the student with working knowledge of virtualization products, such as Oracle VirtualBox, VMware Workstation, Microsoft Hyper-V, and VMware vSphere. Right, so we'll see about those. Some of your assignments will be to research, and even a little bit with some of the ones that have free trial versions or whatever, free 30-day trial. Well, VirtualBox is free anyway, which is a nice advantage comparing to VMware. I think I paid like $100. I got an academic discount. I bought it and paid for it myself because I wanted to have it to learn about. But there's also the Microsoft tool, and there's another VMware product called vSphere. Try that again. vSphere. Sphere, yeah. In addition to learning how to install and work with these products, you'll learn how to apply virtualization technology to create virtual data centers. Well, you're going to learn how to do it. That doesn't mean we're actually going to do it, because to really set up a virtual data center would take several $1 million worth of computer equipment. And I went and asked the academic manager if I could have $10 million to buy a bunch of computers. And he looked at me and said, Peter, go and take a vacation. I think you've been working too hard. So we won't actually really be able to do that, but we will on a small scale, right? With a couple of computers here in the room, we'll make some small scale models of that. We'll see about the concept of clustering and high availability. We will learn different approaches to management software. We will implement. Now, another sort of cool new development which is happening, and I've even seen it at a bunch of the colleges I teach at, is something called desktop as a service. So basically, since the beginning of computers, let me just check my virtual class to see my virtual classroom, right? That's another example of virtualization here through Zoom. Just going to check that these guys are here and they can still hear me. Audio level test. So you guys in the classroom, you're still good. You can still hear me. Yep. Somebody in the meeting type yes if you can hear me. I don't think anybody is there. I think I'm going to mark them all absent because nobody is typing yes. Well, okay, they're all absent. I guess nobody is there. Seriously? Oh, well, Navjot Kaur is here. So at least I have one student who's there. That's good.
Yeah, sir, I'm
All right,
also
guys,
here.
thank you for the feedback. So anyway, what we were saying now is what were we saying? Oh yeah, desktop as a service. Shh. Guys, next week, I forgot it this week because I was in a hurry. I have this little like spray bottle of water that you spray houseplants and stuff with. And if you talk, I'm gonna spray water on you, so just be quiet so I don't have to do that. Maybe I'll even spray perfume, which the ladies won't mind, but if guys walk around smelling like perfume, other people look at you funny. So just be quiet so we don't have to do that. Oh yeah, so desktop is a service. So the way that works, like anybody who works at any company these days gets a laptop computer, and managing those laptop computers is actually pretty expensive because pretty much every month they have to update the antivirus. I'm watching you, be quiet. So every month they have to update this and that. Shh. They don't learn, they don't listen, and they don't learn. So I actually spray them with water. They're gonna keep talking, watching. So anyway, it's just tap water, relax, it won't hurt you, but you'll feel funny. Plus it's irritating, it distracts my attention. Oh yeah, so the purpose now, rather than giving our employees more and more sophisticated and expensive laptops, we're thinking about giving them small, simple computers that don't have to do very much, except provide a terminal into this thing called desktop as a service. So employee, gets their computer on the internet, they log in, they get into the company's server, and then whatever they need to do, they do on the server back end, word processing, spreadsheets, financial reports, right, PowerPoint presentations, whatever they need to do. So you see what I'm saying with this, right? Rather than giving thicker and fatter and more complicated clients to our users and having all the processing power local on their end, we give them very thin clients that don't do very much, except I hear somebody crying. If any of you guys need to take a nap or something, because I have 2 children, they're in university now, but I know when small children get tired, they start crying. So if any of you kids need a nap or something, just go and take it. Anyway, so we give our employees very lightweight, inexpensive computers and a couple of advantages. Number one, we don't have to keep supporting those, right? We don't have to do stuff to update the software on them. Number two, if they lose it or something, or if it breaks, we haven't lost very much. So anyway, that's desktop as a service, one of the concepts we'll be looking at. Yeah, so that was virtual desktop environment. And leverage cloud computing to build or extend our data center and provide disaster recovery services. So these days, as more and more stuff gets to being run on computers, disaster recovery is a big deal. So if there were some kind of an earthquake or a fire or something really bad happened, we would want to be able to quickly recover the company's computer assets. So anyway, that's disaster recovery. If you walk into a police department or a hospital anywhere now, behind the desk, they have binders with all of their procedures, right? All of the things they do to deal with every situation. Because something a lot of these high-level cybersecurity specialists are talking about is there might be a massive cyber attack that would totally destroy the internet and computers would stop working, maybe an EMP pulse or something. So a lot of these organizations now are under a regulatory requirement to keep paper copies of all of their emergency procedures. Anyway, all of that speaks to this concept of disaster recovery. And use cloud computing to build or extend the data center and provide, again, disaster recovery services. By the time you finish this course, you'll have a solid understanding of virtualization concepts, tools, techniques, and products. So there's the book, which is a pretty good book. I bought the book, and I will be doing copy and paste of the most relevant sections for your, your exam studying and that. So I know students never buy the book, so I'll take care of that. I'll get that for you. Course objectives. When you've done with this course, you'll understand how virtualization works and describe the different types of virtualization products and cloud computing models. You will work with Oracle VM VirtualBox, which is free to download, so that's pretty good. Vmware Workstation Pro, which has a 30-day trial, which we'll be working on. We'll understand virtualization software and technologies that are used in data center and cloud-based environments. We will work with Microsoft's Hypervisor. We will work with a virtual machine manager. Well, actually, that's redundant from items 2 and 3 because those are virtual machine managers, as is item 7. We will work with VMware vCenter Server. One of your assignments will be to do some research and present some information on how those products compare. We will implement a virtual desktop infrastructure. Probably we will not really implement it. We will study how to implement it, but I haven't come up with a way in the classroom to really do that because there are no products that implement DAAS desktop as a service, which are kind of available on an academic or sort of free for students basis. So if I come up with a way to do that, well, actually with Linux machines, that would be pretty simple because if you had maybe 3 or 4 laptops running Linux, and then you could use Telnet, but I don't know if we'll really have time to do that. So we'll talk about it. I don't guarantee we'll. The last couple of times I taught this, I tried to come up with a way to implement it, and I just didn't really find something. Because basically here at college, I have to do it with sort of freely available software, which I have not found yet. And we will also introduce the concept of cloud computing, Amazon Web Services, Google Web Services, and Microsoft Azure Web Services. There's probably some other ones out there. Those are the 3 big providers of cloud computing in the world. And cloud computing is a real game changer in terms of the IT industry because in the old days, if you wanted to have computer equipment to run your company, you would have to go out and buy computers. You would have to have space in your office building to keep those computers. You'd have to have skilled technicians to maintain the computers. And now it's like electricity, like the electricity in this room is not being generated here in the building. There's something called Ontario Hydro. Ontario Hydro has several power generation stations around the province. We're probably getting our power from the Darlington nuclear reactor, which is out in Pickering. So we subscribe, just like at your house, you subscribe to electricity and you pay for electricity as you use it on a subscription basis. So the basic thing to think about for cloud computing, it's like a subscription to computing, right? If I need a lot of computing power one month, I use it and they send me a bill. Maybe next month I don't use that much, so I don't have to pay to maintain and own and operate computers that I might not be using that much. So anyway, those are all your course objectives. Let's go and look at some of the content items, which are basically the same thing. Introduction to virtual computing, Oracle and VMware Workstation Pro, and data center virtualization and cloud computing. That will be our first 3 to 4 weeks of class. Working with Microsoft Hypervisor, working with Virtual Machine Manager, working with VMware vSphere, working with VMware vCenter Server, implementing a virtual desktop infrastructure, and introduction to cloud computing. So yeah, that's pretty much going to be, I'll work another couple of topics in there because there is some important stuff going on in today's world, which has not made it into the course outline yet, but that's basically what we'll be studying. So let's go and take a look at our learning plan. So that's also over in your classroom, right? So let's go and look at it. I have some chat comments coming in. All right, so if at any point you want to check up on the course plan, and you should, because I will remind you, but you're also responsible for keeping track of things like the dates of tests and stuff. So don't walk into class and go, oh, test. Nobody told me there was a test. If it's in the plan, you're expected to keep organized on it, right? So. Yeah, so here's our learning plan. Let's go and take a look at it now. So week one, introduce the concept of virtualization. Yep, that'll be our next topic after we do this. Week two, survey virtualization products. So continuation of week one. Week three, the business case for virtualization. How much does it cost and how do we benefit from doing it? Week four, building the virtualized data center. And week four, we will do the lab in class, right? So that's coming up on week four. Week five, we'll have assignment one due, and we'll start assignment one probably next week, right? We'll start to do that and we'll work on it little bits each day in class. And the hand-in will be due on week five. Week six, we'll have a test. What will be on the test? Well, basically anything discussed in the first 5 weeks. Week seven, building desktop as a service architectures. Week eight, business practices, business continuity and disaster recovery. Week nine, assignment two will be due. Once again, I'll kick out assignment two probably around week five or so on, and we'll work on it a little bit in each class. That'll be worth 5% of your final. Week 10 will be test two at 20%. Week 11, understanding virtualization software and technologies that are used in data center and cloud-based environments. Week 11, deploying cloud computing practices, Amazon Web Services, Google Web Services, Azure Web Services, and that will be the basis of lab 2 that we'll do in class. Week 13, all topics review, reinforcement, preparation for final exam, and then week 14, we will have the final exam. So anyway, keep your eye on those dates. I'll announce them, as they come up, but you're also responsible for knowing about them. So now we're going to start studying the PowerPoints, and we're going to start introducing some of the materials. So let's go and do that.
Nice Pepsi.
So all this stuff is in your Google Classroom, right? So for test studying and so on, it'll all be stuff that comes out of the PowerPoints. Whoops, that's not the most up-to-date one. I need a more up-to-date one. Where did I put it? All right, guys, we're going till 6 o'clock today. It is now coming up on 5. It's 10 to 5. Let's give it a little break till 5:05. When we come back, we will pick it up and start going through the PowerPoint. So we're now on break till 5:05. All right, ladies and gentlemen, we'll be starting in 3 minutes. All right, guys, let's do a little Kahoot here to just give you and me a chance to find out how much of what I've been saying you've been absorbing. So the link for it, I'll put it up there in your Google Classroom. It'll just take a couple of minutes, then we'll look at the answers, and that will give you a chance to sort of feed some information back in to the system so we can assess how much of this stuff is being absorbed. All right, guys, the Kahoot link is over there in the classroom, so jump on it and go. And people who are online, you guys do it as well. Go. Okay, go. So the concept here is just discuss, sorry, I didn't type the question out fully. What is virtualization? What did we say about it? Why do we use it? How is virtualization relevant in our desire to construct virtual data centers, do virtual system administration? Virtualization connects to our world, how exactly? Three answers submitted, yay. 4. Ah, 6. I guess the building network's a little slow. It's just some of the answers are still being logged here. Virtualization is creating a virtual version of something, same as the real thing. Yep, that's a good definition of it. Virtualization is an operating system inside another one. Virtualization means running another operating system inside a parent. Yeah, I think you guys are getting this. I think this is good. You've got all of these. In fact, these are so good, I'm going to capture them and store them in your PowerPoint. Because maybe later you can use some of these for your studying. Good answers. Okay, great. I got that. All right, let's go to the next one now. What is virtualization? Actually, this is sort of a duplicate. Sorry, I put this in twice. Just type like the letter yes or no or something to move on, because this is a duplicate question. I accidentally put it there twice. What is a virtual machine? Pretty similar to virtualization, but it does have slightly different things we need to talk about. And we mentioned some different kinds of virtual machines. And now we're going to go and study how virtual machines work. Right, so here some of these answers are discussing what virtualization is, but on the if it's a test question or something, then, and I know we haven't really looked too much at the details yet, but a virtual machine would be a product. See, some of the things here, you're discussing a concept. Virtual machine is a little operating system inside a bigger one. Yep. So that would be an okay answer, I guess. But we're looking more for things like it's a software application, which gives a user the experience of interacting with a complete operating system, even though it's a little window looking into a bigger operating system. The virtual machine takes some of the resources, right? So we might divide up the RAM, hard drive space, networking capacity, and other factors of the host, and make them available to smaller little windows on the host, which are the VMs. Yeah, pretty good. Those are okay answers. Great. Oh, I have another one here. What does an operating system do? It controls the hardware. It controls users. That's what it basically does. I'm going to kick this chart out later on after class. I'll add another couple of things to it based on our lecture. But essentially the my computer's running really slow here. I don't know what's wrong with it. Maybe it's the Zoom call or something. See, these are all tasks running on my computer, and in future classes, we'll use things like PowerShell to create some instruments to control, to measure and control these tasks. So I'm trying to look at my Visio chart right now, and it's not showing up because I'm out of CPU resources to work with this. Question? Oh, come on in. Yeah, hi. Come on.
I just need to do a quick measure.
I guess so. Go for it. Yeah, so anyway, in terms of the operating system, what I was trying to get from my Visio diagram, but it's not cooperating right now. I'll export this out to a PNG later. The concept here is the operating system controls. Oh, do you need me to move or something? Am I in the way?
Just the middle here.
Oh. Yeah, you got it. Yeah. So yeah, the two things we have to work with, remember we said our hardware and users. So the operating system controls those two things and the connections between them. Yay, NBBV got third place. Gary got second, and first place goes to Kirat. So it's good if you use your real name in these things because participation does count a little bit to your final mark, and I just like to keep track of who's doing what in the class. All right, so that's pretty good. Now we've got about another, what is it? Another 30 minutes, roughly 35 minutes. So let's start looking at our PowerPoint now. Right, so here's our topic, virtual systems administration. Just waiting for my light pointer to come on. For some reason, my system's really dragging. My light pointer is not working. I like it when I use my light pointer. Makes it easier for me to concentrate. LG Tech. Ah, there we go. Right, so when you see these windows over here in this graphic, that's from your textbook. The concept is virtual computing is like creating little windows into another computer system. It could be the hardware box physically in front of you. It could, whoever's talking over there. This is not only a light pointer, this will dispense a charge of 10,000 volts. So I'll zap you with it if necessary. So just be quiet so I don't have to do that. I mean, I don't mind doing it. I'm not sure if some of the voltage will go back into my hand. So I don't have gloves today. If I had gloves, I'd exactly no problem. So anyway, these are like little windows that are windows into another computer. That's what virtual computing is. Two key elements of this course are virtualization, meaning when we're working on one computer, when we're using Oracle VirtualBox or VMware on the computer in front of us, and we're potentially creating multiple VMs, multiple virtual machines on one box. The other concept is cloud computing, because cloud computing just means that we're accessing a computer somewhere else on the internet with Telnet or some sort of remote access terminal. So this is stuff that we've already talked about. That's from your course outline. I'm not going to read through that again. Well, actually, some of the things that I brought into this by myself are using PowerShell scripts to do Windows system administration, case studies in Google, Azure, and Microsoft. And that's pretty much my own stuff. The other stuff is stuff in the course outline. So here we have how our marks break down. So 2 labs at 5% each. Professionalism. So you chatty Cathy's over there who we're talking. There's a computer, there's a cloud computer here in the room noting you're talking. And every time you talk, it takes one of your marks off. So 10% is actually a lot, right? That could be the difference between like a C+ and a B+ or something. Also things like participating in class and just generally showing interest in the course all counts towards that. Assignments, 2 assignments worth 5% each. 2 tests worth 20% each, and the final exam. And in terms of the tests and the final, the class marker quiz you did today will be a very sort of typical example. That'll be the test tool we use, so you get used to using that as well. You can see in some cases, I mean, the questions aren't going to be exactly the same, but the wording might be different, but the general types of questions will be very similar. So when you're wondering what to study, well, study those review attendance quizzes I'm going to be giving you each week. Right, so once again, that's from your course outline, so not going to read through that whole thing again. What is computing? What is a computing device? And in a future class, maybe next week, I'll bring in some, I don't know if you guys have heard of Arduino and Raspberry Pi. They're little one-board computers. I don't think here at this college, I don't think we have an embedded processor program, but at Humber College, I teach embedded processor, and we use Raspberry Pi. And the nice thing about it is that it's a fully functional computer, but it's basically small enough and cheap enough, like $10, $15. I can bring in a couple of them and we can hook them up and we can see some of the things that computers do when they network. So a computing device is basically a device that can take in digital information and run instructions called programs on a CPU, right? There's all sorts of definitions of what a computing device is, but that I think is the simplest one. We can run programs, we can transfer inputs, we can convert, translate an input state of data to an output state of data. So server administration is the set of activities that adjust the computer to optimize the kinds of things we need it to do. One of your assignments will be called the NotPetya case study. NotPetya was a virus that damaged, right? It destroyed a lot of computers in the Ukraine about 9-10 years ago now. And it's a very good case study of the kinds of things that have basically the reason the damage of that, they say they estimated it cost $3 trillion of damage to the companies involved. And that's a good example of why what we're doing is important. Because the reason NotPetya happened was because the server administrators did not do things which were very basic things for them to do. Things like Windows operating system patch updates, maintaining the antivirus, shutting down ports. If you don't know what a port is, we'll talk about networking next week. So closing off ports that did not need to be open, right? Any one of you by the end of this course, you would know enough that if you would have been in charge of those computers for that company that got blasted, you could have prevented it from happening. But the server administrators were lazy, I guess. They didn't do the job. And being a server administrator is kind of I don't want to say that it's boring, because if you like technical stuff, it's very interesting. But in a sense, it's kind of unsatisfying, because if you do the job properly, nothing ever happens. Right? You go home at the end of the day, your wife says, "Hi, honey, what happened at work today?" You say, "Oh, we had an amazing day." She says, "What happened?" "Oh, nothing happened." No viruses, no computer intrusions, no data loss, right? No users got damaged or something. So nothing happened. So I did my job. Well, anyway, here is some things from a previous class, right? We were talking about BIOS chips at the beginning. So BIOS is, that's what it looks like. It's a little chip on the motherboard that when it gets power, it works. The only thing it does is work for about 3 or 4 seconds to run some self-tests on the motherboard, find the operating system and load it, pass off control to the OS, then it doesn't have to work anymore. So that's a pretty good job, right? It works for like 3 seconds each day or something. So when you power up the computer, yeah, so that's something we already said there. The operating system allows or denies user account access to resources. When you apply power, how do you manage the work of bootloading? Yeah, so that's something we already talked about, the bootload process. I don't know if it's a thing anymore. I remember when I started here, a very big program was the A+ certification for hardware technicians. I don't know if they still have it, but that's the kind of thing they would talk about there. That's your textbook. So anyway, that's what I'll be lecturing from some days. I have the electronic copy, so I can copy and paste sections of it into your PowerPoint as we need them. This course will teach students about virtualization as it combines theories and concepts with hands-on activities and projects that allow the student to develop a working knowledge of leading virtualization products, Oracle, VMware, Microsoft. In addition to learning how to install and use these virtualization products, the student will learn how to apply virtualization technology to create virtual data centers, to use management software, to implement a virtual desktop environment, and to leverage cloud computing to extend remote computer capabilities. There's some stuff from before, right? So when I taught this before, I put my class recordings up. I mean, not that they're amazing. I'm making class recordings now for our online people. So if you want to go and review any class, you can watch them. But if for some reason you really desperately desire to see my notes from the last time I taught it, you can go there and review that stuff. So in 2021, 67% of respondents to a survey said they're using Microsoft Azure for cloud services. So that would tell me, if I was your age and if I was looking to get my foot in the door of my first job, getting some Azure certification sounds like it would be a good idea. It's not very hard. You can take online training. Well, actually, just the training we're doing here will get you about 60 or 70% of the way. And if you desire to look at getting cloud certified, let me know. I have more things I can tell you to help you with that. Right, so here's more stuff about Microsoft Azure, VMware and virtualization. To conceptualize VMware, think about boxes within boxes. So some applications live inside the VMware, not directly in the operating system. So this is the idea of a hardware abstraction layer. So you have your physical resources down here, your actual computing hardware. And imagine this whole thing was Microsoft Windows, right? It's Microsoft Windows. And then a program like a Word or Excel or something is an application that runs in the operating system. But before the application can connect to the hardware, it has to go through this thing called the hardware abstraction layer, which is also called a hypervisor. And they started doing that, I think, about 2005 or so. It's been around quite a while now, over 15, 16 years, because there were a lot of computer viruses back then, and viruses worked by application code getting directly into the hardware, things like the CPU registers and stuff. So in Microsoft Windows, they put this thing called the HAL, or the hypervisor, And that would require an app. Somebody over there is talking. It's very distracting. I'm going to come over there and zap you with this. I will. I don't know if it works yet. The problem is, well, I mean, I think they're okay now. But last term, I did zap a student with this and the voltage was turned up a bit too high. Suffice it to say, before that, they had beautiful long curly hair. And after that, they sort of look like me. So you probably don't want me to test this on you. So just be quiet so we don't have to find out. So anyway, the way things work now with the Microsoft hardware abstraction layer is programs have to be written before they can go to the hardware. They have to go through the HAL. And one of the things that happened as a result of that is that older computer application code could no longer be used. So people were kind of pissed off about that. They had to go out and buy new versions of all of their applications, because when they got new computers with this new CPU microcode, it would no longer work with the older applications. Same thing with Windows 11, right? Be very cautious before you upgrade to Windows 11, because it's doing a lot of shenanigans like this as well. In Windows 11, if you put that on your computer, and I'm not going to, right? I will go to a pure Linux environment. If it ever gets to the day where Windows 10 stops being supported and I have to go to Windows 11, I'm just going to go over and start using Linux. But the point with Windows 11 is that among the other things they have that are horrible, there's a list of allowed programs. So if you have some software that you like to use, but it's not in their allowed list, you will not be able to use it on Windows 11. And also with Windows 11, Microsoft gets to decide what kind of data you can have on your computer. So it's very draconian, right? It's very fascist. So basically anybody who knows what's going on is not. That's why you don't hear much about it. It's been out for a couple of months now. It seems nobody is updating to it. And one of the things we'll get out of this course, maybe by week 6 or 7 or something, we'll do a deep dive into that, because that's sort of like a good case study of what's going on currently with operating systems. All right, it's 5:35. We'll go for about another 20 minutes and we'll wrap up the class. Availability zones are a concept in terms of cloud services. So when we do our labs on Google, Azure, actually Azure does not use availability services, but Google and Amazon Web Services, that just refers to the fact that depending on where you are in the world, there will be certain server farms you can use. It just has to do with network bandwidth and stuff like that. Kinds of services we can get from cloud services, that will be one of our labs. Term hypervisor we already defined. Here's some examples of final exam studies. We'll build this up as we go forward. More stuff on virtual machines. I think I've already talked about a lot of this stuff now. So workstation, and I wish if I could demonstrate, I meant to demonstrate my own VMware, but I forgot that I was doing stuff on the weekend. I moved it over to my external hard drive that I don't have. So I'll demonstrate it next week. But basically it's an application, you start it up and then you configure the way it works. If you have VM Workstation Pro, that's the thing that lets you create ISO files. An ISO file is like, it's a file, a data file that wraps up, that provides an entire configured operating system. So if I give you an ISO file, which I made with VMware Workstation, and you have VMware Player, which you can get for free, by the way, it's freely available. You can run my ISO file, you can open it up, and you can get a simulated version of the operating system that I created with a certain database, with a certain network configuration, with certain user security permissions, with a bunch of other stuff. Now, closely related to VMware is another concept called Docker, and we're going to talk about the difference between VMware and Docker. It's not on the course outline, but it's I think because course outlines are always about 6 or 7 years behind what's actually going on in industry, and Dockerization really took off a couple of years ago. So that's another thing we'll get to. So Workstation lets you create ISO files. That's the thing we're gonna do in the lab. I bought it for, I think 140 or something. I told them I was a professor. They gave me an academic update. I think you could get a free 30-day trial without having to enter credit card information. If we can do that, then I'll get you to use VMware Workstation Pro for your lab. And if we can't, then I'll just give you some ISO files and you'll run them. So Workstation is what lets you play these ISO files. Once again, an ISO file is an output from VMware. You make the ISO file, you give it to somebody else, they take it and play it in their VMware player, and then they can reproduce the operating system environment you had. There's test one study syllabus. I'll probably change things around a little bit. When we get closer to the test, we'll come back and look at that. Now, here's some stuff at this point. This is probably around week 3 or something. We're going to move forward to Microsoft Windows in terms of networking and Active Directory. And because we don't have the ability to set up a real network, we'll just sort of discuss and we'll create some simulated networks. But we'll see how when we connect these computers together, we create Active Directory records to make the Windows network. Anyway, that's what that picture is. And we'll go into these details, horizontal and vertical connection schema. And then we'll get into the business concepts of it, total cost of ownership, cultural factors, right? So once you become a manager at some technology company, you're going to find out that there's how the technology works and there's how people's thinking works. And if your users, if your sort of community of people within the company don't like a certain way of doing things, it's called cultural factors. It doesn't matter how great the business need is, they just won't cooperate and go along. Societal factors, government and public policy, and licensing considerations. We'll see how different product license fees affect the way you do things. Desktop as a service, right? That's another thing where we have a separate lab worksheet on that. VirtualBox versus VMware, that'll be one of your assignments. Here was answers I got from students in a Kahoot in a previous class. What is a virtual machine? They came up with better answers than you, but that was after we'd studied it a couple of weeks. So in a couple of weeks, you guys will be pretty good as well. Elements of a computer system, that'll be another final exam question. Discuss what we mean by virtual server administration. You can go and read through all of that stuff and study it. In traditional computing, a physical computer supports a single operating system. The operating system provides an environment. By the way, that sounds like a good final exam question to me. What does the operating system do? Provides a virtual environment for applications and manages the physical computer's hardware resources, CPU, memory, hard disk, and input-output devices. During installation, the operating system is configured to the computer's hardware environment with a specialized kernel, along with a variety of hardware drivers. We're going to see later how an operating system is basically 2 parts, right? It's the kernel plus the device drivers, but it's too late today to get into that right now, so that'll be a future lesson. This hardware dependency makes it difficult to move an operating system from one computer to another without reinstalling on the same hardware. That's why we like Docker, for example. Dockerization is similar to VMware. The difference with Dockerization is that I make a Docker file and I have a Docker container, and the Docker container handles all of the details of the interaction with the application code inside the Docker image to the host machine. So it exactly gets around this problem they're mentioning here in point number 3. But if you're not following all of this, this is just an introduction. We will have detailed lessons on all of these things over the next weeks. This is something you can try filling out for yourself as a class exercise when we talk about a difference between type 1 and type 2 hypervisors. Basically, a type 1 hypervisor is what they call a bare metal hypervisor. It's intended to be put directly on the computer hardware. A type 2 hypervisor lives as a guest inside another operating system. So VMware, for example, needs Windows or Mac or Linux to run inside of. If it was a type 1 hypervisor, I could load it directly on the hardware. Now, here's a question I'm still thinking about myself. I haven't figured out the answer to this question. And maybe I'll make it a final exam question. Maybe some of you will come up with some good ideas to help me. What is the difference between a type 1 hypervisor and can anybody finish the question? Based on the discussion, let's see if you could understand what I'm saying enough to finish putting this question together. Because when you can ask meaningful questions, trying to come up with meaningful questions is the best way to teach yourself any new topic or something, right? So that's why they say that professors are such big experts on the things they teach. It's not because we're smarter than anybody else. It's because we have to come up with test questions, and the act of coming up with test questions really focuses your understanding. However, you're allowed to come up with questions by yourself, even if you're not a professor, right? Maybe nobody but you will use your questions, but the act of inventing questions is a very powerful way to get the human brain to process information and understand it. So what do you think my question is here? What's the difference between a type 1 hypervisor and what's the XXX part? While you're thinking about it, I'll go and fill in some of these slides a little bit. So, a type 2 hypervisor, what did I say it is? I said it 3 minutes ago. Let's see who's paying attention. What's a type 2 hypervisor? Akashdeep Singh, what's the type 2 hypervisor? Well, we're going to put a -1, meaning a question asked, not answered. But if you answer the question, that could be a +1 or higher, depending on the quality of the answer. And basically, I'll add these numbers up at the end to see what your final grade is. AJ, what's a type 2 hypervisor? No, AJ, absent, took off. Amrinder Singh, what's a type 2 hypervisor? Louder. They were talking when I was lecturing. That's why I know why they didn't hear, because they were chat-chatting instead of listening to me. Now, if you ever actually want any good answer, go and ask the ladies, because for some reason, the ladies always seem to know what's going on here. I don't know why it is. Women are smarter than men. I know my wife told me that, and she's smart, so she must be right. Gagandeep Kaur, what is a type 2 hypervisor? Gagandeep, are you here? What's a type 2 hypervisor? It is yeah, you're going in the right direction. It is a guest that has to live inside a parent operating system. So lives, works, functions as a guest inside a operating, like VMware runs inside of Windows, for example, inside a parent operating system, like VMware, once next week when I can demonstrate it to you, runs as an app. Application inside Windows, for example, or Mac or Linux. All right, so what was probably my question over here? What's the difference between a type 1 hypervisor, which is a bare metal hypervisor, which runs directly on the CPU, right? There's no other operating system kicking around. And an operating system, right? That's what I'd like to know. Because I think that Linux or Windows or Mac OS would count as being a type 1 hypervisor because it gives you an operating system that runs on bare metal. So I'm trying to figure out what's the difference between a type 1 hypervisor and Linux, for example, or any other operating system. Maybe in the coming weeks of the class, we'll figure that out together, and then you can help me understand that. So potential final exam questions. What are the elements of a computer system? What's a server? We'll talk about that next week. It's getting a little bit late now, and I'm running out of steam. What is server administration? How do we do it? Why do we do it? Discuss the 2 ways to administer a server virtually. Well, we haven't talked about that yet. We've talked about these other things. What do we mean by a data center? Cloud computing is the way of running a virtualized data center. What is cloud computing? How do we do cloud computing? Why do we do cloud computing? Those are your test questions. And over the next several weeks of class, I'll tell you the answer. So if you don't get the answers, you have only yourself to blame. But don't blame yourself, just get the answers. It'll feel better. How to get top marks on a test question. By the way, this is true for every test everywhere in the world. We'll talk about it next week because I'm tired to talk about it now. Next week, we'll talk about PowerShell. More stuff about virtual machines here. All right, guys. So for next week's class, read the PowerPoint. It's in Google Classroom. And then we're going to talk about things like Active Directory, policy documents, and other stuff. All right, guys, it's pushing up. It's about 10 minutes to end of class, but I'm going to end the class now, and then we'll pick it up again next week. So if you have any questions or something, you can ask me. Otherwise, we're going to end a few minutes early. So class dismissed. See you next week. Bye. So remember, next week, you guys will be linking in virtually, and our session B people will be coming here to the class. So now you can, like, you're welcome to come to the class anyway if you feel you get more out of it. Probably for right now, we're just doing some introductory concepts. When we get more into the details of it, some students get quite interested. They want to come and get more out of it. So you're welcome. I won't tell anybody if you're supposed to be online and you come into the building, but you do have to be here physically in person for your assigned days, or I guess they get mad at you when they laugh at you or something. I don't know what you do in that case.
Guys, class is over, you're welcome to sit here, but class is still going.